Thank you very much, Han. Thanks everybody for joining. I think we have a pretty good session here today because I think this is pretty topical. We like to think a lot about or we know the cost of actually application downtime. We can calculate it, but I think some of the things that we don't really or have a hard time calculating the cost of is what's the cost when my monitoring and observability platform is unavailable? So what we'll cover for this is, specifically for cloud native, what are the unique requirements for observability in a cloud native environment? And as we know with cloud native environments, we think that reliability is a much more important topic. And it's a much more challenging thing to deal with and we're going to show you exactly why. And we'll talk a little bit about some of the finer points of SLAs and understanding, what questions to ask your vendors and how they calculate SLAs and, what they promise versus what gets delivered. And then we'll focus on, okay, what are the three big categories of costs when you have either downtime or performance issues with your observability platform that you might not be aware of. And then we'll, show what really good observability looks like and what reliability and what the benefit is, especially in cloud native environments. So let's just jump right into it. So again, we know we can calculate pretty well what the cost of application downtime is. There are websites that do this for us. There's no mystery to it. But, Amazon kind of leads the pack with, when they experience a downtime event, there is a huge revenue impact per second, almost $3,700 per second of revenue. And, what percentage of that is recoverable for all of these vendors? That's something that they have to calculate and factor into things. And even outside of retail, you look at social media, the big British Airways outage that happened back in 2017 was in excess of $100 million of revenue lost in just a week. So these things we can kind of calculate, but the harder thing is figuring out what's the cost when my apps are still up, but my observability system is down, or I can't extract data from it. Even if it's just a partial outage, not a full outage, what is the cost to my organization when that happens, even though my app may still be up and running? And to take a step back and say, why is this such a unique challenge now? We have to think about how architecture has changed right now. In the old world, and I remember this very, very well back, and lived this, when you had a central infrastructure and operations team that was really the tip of the spear that would monitor everything. And it was a very hierarchical structure within the IT department. And your applications were designed that way as well. So you had pretty good alignment between how your applications and infrastructure were built, deployed, and monitored, and who was responsible for doing so. So you had monolithic apps running on virtual machines within a data center, and then eventually moving it to more public clouds. And the I&O team was the center of the universe. And they were the ones that were responsible for triage. Is this outage, does this belong with, do I need to go to the DBA? Do I need to go to the developer team? Do I need to go to my systems analyst, my infrastructure team, security, whatever it was, and a big knock, the network operations center that would actually triage and troubleshoot these events. And at that scale, this was manageable. In today's world, it is a very different animal. We have, in a cloud native environment, we have all of these interdependent but separated microservices running on a fleet of containers. And now dev teams are at the center of the universe. This is, a central I&O team can't be in control of this anymore. Things move too fast. The infrastructure is too varied. And it's really the developers that have to have, full visibility into everything from the container up to the application level to all the microservices and the code level issues. And so everything starts and ends with the developer teams that have to monitor this very complex, interdependent, and very dynamic, ephemeral environment.
Yeah, George, I think just to piggyback on that, I think the ephemeral nature of this environment on the right is one of the really, really important things to point here. On the left, you have, by design, a very stable system, not designed to change out from underneath you. And by design on the right, things are appearing and disappearing all of the time, especially in the containers world. And that just adds a different level of complexity.
Yeah, no question. It's the old pets versus cattle analogy, right? Everything on the right-hand side, it's cattle. And there's the benefit to that, right? I can, if I need to update an individual microservice, I just create a new one with my changes and then just swap it out. And that, so, a microservice or a container can appear for minutes at a time and disappear minutes later. And being able to monitor that in this world is just an entirely new complexity. And again, and then second to that is just the instrumentation that's required for this. In the old world, it was just I had an IT and systems management platform, and I put agents on everything, and it was pretty simple to instrument everything, and I kind of left it up to the vendor. But in this new world, instrumentation is far more complex. We've also got a lot more open source standards for data ingest, of course, with like Prometheus, OTel, et cetera. And so we're kind of shifting from this world of vendor controlled data collection to now data, ingest and control being placed more in the hands of open source standards, and given the developer teams much more control of the data that they want to collect. And that can be good and bad, because they might collect a lot of data that is not useful and is very expensive to keep for a long time. So it's not just the infrastructure being more complex, but also how you monitor this, the instrumentation and the data collection that is very, very different.
Yeah, and this graphic clearly points out the cardinality problem that anybody who has moved from the left-hand side to the right has dealt with, and this, I think, does a pretty good job of depicting why that is in fact the case.
Yeah, you go from, the same application that used to be able to run on 10 VMs is now running on 100 or 1,000 containers, and each of those containers emitting the same volume of metrics data as the VMs, and it gets quickly out of control. And also, you have the developers, as you mentioned, Joel, right, that are adding all these different fields and metrics that they want to capture, and you get a cardinality explosion, and it gets really, really hard to control. And when that happens, that volume of observability data goes through the roof. All of a sudden your dashboards start loading slowly, or the queries don't run at all. And those performance issues have you kind of flying blind with an application that's critical to a customer experience. And so when we make this transition to cloud native, some of the problems and some of the things you need and the problems that it kind of creates here is that, developers have to have access across all the applications into the infrastructure. That one of the things that notes or kind of distinguishes observability from monitoring is the full stack nature of it, right? And secondly is that a lot of traditional APM tools that were very good for the cloud world start to fall down in the cloud native world. They were never, microservices, containers were not a thing when most APM vendors created and invented their solutions for monitoring application performance, even in a cloud environment. And the sheer volume of data begins to overwhelm those systems, as well as just, again, the things that developers need and want to analyze in that environment puts a lot of stress on them. It's not uncommon to see dashboard sprawl and dashboard entropy, where especially a newer, less experienced engineer has to fish through like a dozen or more dashboards just to find the right one for whatever issue they have to go after. That becomes a real problem. And of course, and the container model it breaks the economics of a lot of traditional infrastructure monitoring tools. They were not designed for that volume. And so, if your provider's, charging you for both data ingest as well as persisted storage, then they're charging you for data that may not be useful. And then when you do your analytics and try to keep only the useful stuff, you're paying for that too. And that model breaks down with containers. It's not sustainable over the long term. And so what's the end result of that? In a survey that Chronosphere did with a vendor, I think was it ESG, and I can't remember, and often having a brain cramp on who we did the survey with, but we commissioned a survey, and some of the results that came back for this, only 1% of companies meet their self-identified MTTR targets. 99% don't meet the targets that they set out for themselves. That's an amazing stat. We were surprised when that came back. That's really something. And then their engineering teams dedicate 25% of their time on troubleshooting. That's a quarter of their time is spent just troubleshooting stuff. That's time not spent doing new and innovative things or creating new features and capabilities. They're just fighting fires. And they have an over 12x increase in observability data, which again drives their costs up. And again, that data volume can kind of overwhelm existing systems, whether you've got your DIY observability tools that you kind of cobble together yourself, or using an APM platform, the volume of observability data can overwhelm your dashboards, slow things down, and make it very hard to sift through all this data and get to the right data in the right context to fix an issue.
Yeah, I think it's interesting if you look at these three facts on the left, how they build from the bottom up. Because of all of this explosion of data and cardinality, engineers are less efficient because the signal to noise problem just gets really, really difficult to manage. And because of that, resolving incidents just becomes really challenging in a world where you don't know exactly where to go or exactly which data is going to help you out of the situation that you find yourself.
Yeah. And so the reason we kind of point this out in this architecture, and this is probably motherhood and apple pie to many of you on the session, right? You're already living in this world, but is to really point out how the reliability of your observability platform is such a crucial piece when you have this kind of environment. It's far more important than it has been with traditional cloud infrastructures. When even you have minor outages can be a major problem. When you have such a complex distributed architecture with this volume of data. And so there are some pretty much, some things that you absolutely have to have for observability, especially in a cloud native environment. And of course, the first thing is that the developer teams absolutely have to have that visibility through the full stack, from the application all the way down to the infrastructure. Importantly, they need to be able to get really fast access to the right data and in the right context. It's this idea, this thing I mentioned previously, right? Which is the enormous amount of data out there. The ability with some of these tools, I mean, anybody can create a dashboard. They can copy a dashboard. They can tweak it in one minor little way. And then the next thing you know, you've got a new engineer with 6 months of experience has an outage that it's their turn on the on-call shift. And now all of a sudden they have to sift through how many dashboards to find the right one that can give them the right data to solve an issue, because nothing is in context for them. And especially when you have all of these interdependencies of microservices, I might be pretty familiar with my own microservice and maybe the one that's right next to me, but the one that's 6 degrees of separation away that somebody made, a configuration error of some kind that cascaded throughout and is affecting my thing. Like, I can't figure out where the source of the problem is because the data is not put in context. That's a real challenge. And thirdly here, observability should only charge you for data that has value. That seems obvious. It's just not the truth today. Is most observability or application performance management tools charge you for data ingest and then what you persist. So regardless of the value of the data, you're paying for it. And they generally don't provide a whole lot of tools to help you sift through and find the data and only keep what's valuable, because their incentive structure, since they're charging you for the volume of data, is to have you ingest as much as you can. And most of the default settings are the spigot is wide open until you figure out how to fine tune that and reduce the data volume. And really importantly, is that it be usable by all engineer levels. Your observability stack needs to be something that should not just be in the hands of your power users. And I know, Joel, like tracing, of course, is like one of the top things that ends up being just a power user tool. You really need observability that can be used by everybody so that you're not constantly escalating to your most expensive top tier engineers. And so let's talk, we're going to get into now the specifics of what are the costs of poor performance, poor reliability. And I bring up this, everybody should probably be pretty familiar with this quote, right? It takes a long time, 20 years to build your reputation, to get your customers to love your product. And it takes about 5 minutes to ruin it. If you don't think of it that way, you really should. And we had some other survey we did with ServiceNow, did a CX survey. And I think it was something like 61% of customers will leave you with one bad experience, which is amazing. So these kinds of things are crucial to the success of your applications. So you can do all the things right for a really long time, and one mistake loses you a customer that's not recoverable. So it's really important to think about the SLAs, right? And it's not just what they promise, but it's what they can actually deliver. And I think just to put this in context, right? The chart shows you based on the SLA guarantee how much downtime that you'll face. And, even at 99.8, which not a lot of vendors offer, I think it's probably more common to see 99.5. At 99.5, you're looking at almost 9 hours per year, and just on a per month, 43 minutes per month at 99.9. I'm sorry, 99.9. 99.5, it's like 3.6 hours per month of downtime. So these things add up, and trying to get from 99.95 to 99 to 4 nines is no trivial task. And it's also, like, what is the cost when your customers find out about an outage before you do? Your customer should not be calling you and telling you about an outage. You should be able to know that before it happens. And the thing is, and I think, and Joel, you were really crucial in pulling this together, right, is to understand, right, it's not about the big total outages. Those make the news. We had a fairly large one fairly recently, and it was kind of some of the impetus for putting together, this, some of this information, is that we did hear from some customers say, well, my application stayed up. So it was disruptive, but at least my application stayed up. And that's for a total outage. But again, what is the cost to you, even if your applications do stay up? And you have to make the distinction between, like, what's a total outage? And then there's also partial outages where the SLA probably isn't even violated, but there's some aspects of the platform that aren't functioning, or you just have performance that degrades. The intermittent outages are incredibly disruptive because they're a constant firefight. You'll have lost data, your traces may be totally unavailable, a cardinality spike, you'll get no alerts for like 15 minutes, or data arrives late, like, are your alerts stale? So those are like the intermittent or partial outages that can happen pretty frequently. And also the performance issues also have a huge cost. As I mentioned earlier, right? Either dashboards are slow to load, where your engineer is just sitting there watching the spin and waiting for the query to return, or they don't load at all. And basically your engineers can't work when that happens.
Yeah, a couple points here, George. First, I guess maybe most importantly, you referenced an outage. That was not a Chronosphere outage. We were talking about the industry as a whole. So there was a major outage in the industry. It was not Chronosphere's outage in that particular case. And then I guess speaking specifically to intermittent outages, that was a total outage. So everybody knows very quickly that something is wrong in those cases. Intermittent outages can be challenging because you're not even exactly sure what is going on. Is it that my observability provider is having an issue? Is it something on my end? And so you actually spend a fair amount of time in discovery before you even understand that the problem is not yours and you are a victim of an outage by your observability provider. And so that creates churn and lots of waste inside of your engineering org.
Thanks. And thanks for clarifying that, Joel. In my desire not to like kick at another vendor and drag them through the mud, I didn't mean to almost impugn us. It was a very well-known, a very well-known outage in the industry. And, and I think, not, we don't kick a company when that happens, but we did hear from a lot of some customers, and we have some shared customers, right? That one of some of the challenges there was, yeah, apps are functioning, but even if they're up, I can't do much with them if I can't have visibility into how they're functioning. So getting to the meat of the matter here, what are the 3 big costs that you should be aware of that you are likely going to have to communicate upward after the fact, that you may not be thinking about when observability is unavailable or performing poorly? And the first thing is that the business generally stops. When your observability doesn't function, even if my apps are up, I can't do anything. And so I use the airplane here as a kind of an analogy for this, because, if all the instrumentation fails in the planes, generally you can get it onto the ground and you can say at the end of the day, hey, it was successful, we landed the plane. Well, there was probably a ton of disruption in that process of getting that plane onto the ground without instrumentation. There were a lot of people had to be involved, and it was an emergency. It diverted other planes. It was a huge problem when that instrumentation fails. And similarly with the business, right? Sure, my apps might be up, but I can't use them. Very common is deployments have to stop. If my observability platform is not available, I have to tell all my engineers no more deployments until we get this back up and running. And if you're making 100 or more, 1,000 deployments a day as a big company, that's hugely disruptive and costly, because eventually you've got to make that all up. It creates a big backlog, and it's very disruptive to the company. If you're a financial services firm, you've got to stop trading if that's what your business is. An e-commerce site, you can't transact. When the audit trails are broken, transactions, you can't complete them. So it's hugely disruptive. Basically, yeah, everything is up and running. It's only my observability that's down, but basically my business has to stop until it comes up. And it's pretty routine. Like, no, DoorDash is a big customer of Chronosphere. Before they used Chronosphere, one of their big problems was things like this, minor things could shut down their developers for a while. And it would be the developers that could break the entire system with some very minor change. And it wasn't something they anticipated, and the whole system's not available. And that could happen fairly frequently. The second thing is just the amount of troubleshooting. And we already mentioned, like, engineers are spending 25% of their time troubleshooting. And when your observability platform is unreliable, it's up, it's down, partial outages, of course, troubleshooting simply takes longer. And this is like, I just went through this, like the windshield, right? Your visibility is limited. I can see the taillights in front of me, but I'm driving really, really slow, and it's very disruptive when my visibility is impaired that much. And I actually just went through this on a trip back from New York to Boston, where I was always just keeping an eye on the red taillights in front of me to get home during these downpours. There is a cost to managing and trying to keep your environment going when your observability is not functioning. I've got to chase metrics from other sources somehow, whether it's, through AWS or Google or whatever I have internally. Your traces may not be available at all. I'm pulling engineers off of other important tasks. And then you've got to research the impact, write the postmortem, and feed all that information up. And you may have permanent data loss, which means any trend analysis that you do is broken. I don't know if there's anything else you want to kind of add some color to.
Yeah, having worked with teams that have been in this situation where where observability is either fully or partially impacted, it just there's a loss of confidence in what you can do that can paralyze an entire engineering org. So even though everything, as far as you know, is up and running, there is just this this sense of almost fear that we really shouldn't do anything, because anything that we touch and we break, we just won't know it. And it becomes quite an impact on organizations especially when you get into these cases, which again, I've seen in past lives where it's almost flapping a little bit. The observability is there and then it's gone, and then it's there and then it's gone, because the vendor is having some intermittent outage issue, and it creates an immense amount of time and churn inside of an engineering organization when they just can't trust what they're seeing anymore.
Yeah, it's a really good point. And that kind of leads to the next cost to your organization, right? Is engineer burnout. And this is something I think everybody's pretty well aware of, right? And, and what happens is the engine, as I think you've stated many times, Joel, right? Engineers are a resilient bunch. They'll do what they need to do and work around what they need to be able to work around. It takes a toll on them in terms of just the hours and frustration, how bad on-call shifts can get. And there's just, generally speaking, this over-reliance on the institutional knowledge that's kind of in the heads of a few important people. And if they leave the company, it's a huge problem. So this type of endless firefighting carries a long-term cost.
Yeah, this one cannot be emphasized enough. The human cost of having your observability down is real. It's hard to measure, but make no mistake, it is real and goes to the bottom line of your company.
Yeah, we've actually brought on some former SREs into Chronosphere in new roles here because they were just so burned out at previous companies. So it's actually kind of helped us, but it's not going to help you when you lose your most valuable engineers because they're working long hours and missing their kids' birthday parties and other stuff because they're constantly fighting fires when their observability is not available. So what can you do about it? And that's what we're all here for, is right. If you weren't aware of these three things before, you certainly are now. And then what are some of the things that you can do about it? So we want to talk a little bit about the Chronosphere platform and show you a couple customer examples and see what the actual changes were. So if you're not familiar with Chronosphere, it is a single tenant, like SaaS-based observability platform. So it brings in metrics, trace data via open standards. And here's kind of what's different than a lot of other observability solutions. And first thing is that we put the right data in context. I mentioned that earlier, right? In most observability platforms, the engineers log in, there's so much data, they honestly don't even know where to go to find what they need to solve the problem. So we actually focus individual engineers on the data that's relevant to the problem that they're working on at that moment in time. So it drives engineers through the observability lifecycle, basically know about the problem via alerts, be able to triage the problem so you can explore, analyze within dashboards and traces, and then understand what happened, perform the root cause analysis. And on average, so our customers, on average, customers see about a 50% reduction in their time spent troubleshooting. As we mentioned from our surveys, right? You spend a quarter of your time troubleshooting, but most of our customers have been able to cut that in half. And one of the ways in which they're able to do that is in the center of this graphic is the control plane. It's a very unique capability in the market, and it lets you populate, fulfill all the data needs of your existing dashboards and your alerting needs without having to store all the observability data in its raw form. And so we do that by pre-processing and optimizing the data. The result is much lower cost and much faster performance. And so the way it does that is first, we help you analyze and understand the value of your observability data. So you know what's useful, what is waste. And the way we do that is we watch what you do and how you use the data, and then we optimize the delivery of the data based on your past use. Secondly, we help shape and transform that data based on your need for that data, the context of the data, and its utility. And then you control costs by optimizing those data sets. So you give teams the right data to solve problems faster. And again, as Joel mentioned, right, you're getting that signal from the noise. And the way we do that is we combine the unused dimensions and the unimportant distinctions via aggregation. The third thing that we do with the control plane, right, is you can actually work with your teams. You can delegate responsibility to control data cardinality and data growth. You can set quotas for usage and give teams ownership of that quota and the ability to control their own usage of the data so that they're aware of what they're using. Kind of eliminates that noisy neighbor problem and the problem of one team hogging all the data allocation of your software licenses. And then lastly, the control plane allows you to kind of continuously optimize the performance of the platform itself. So there's platform generated assistance and advice to ensure performance of the platform.
Yeah, one quick thing to add that's on this slide, but just want to make sure that it gets highlighted, and that is we have a single tenant architecture. As a customer of Chronosphere, you are isolated from any problems that might have been caused by the result of another customer making a change that could potentially impact their tenant, but they're fully isolated, which directly speaks to why we can reach the uptimes that we do.
Yep, really good point, Joel. Thanks. And just to give you an example to bring this home, right? So you have everyone's generating data at a resolution of a VM, but now everyone wants to reason about this data at the resolution of a pod. And so instead of every time someone gets the data and queries all of the VM data, Chronosphere pre-computes and gets it to the glass. Everyone gets what they need. It delivers the same results, but with much better performance and a much lower cost. and the engineers never notice. It's not something that they have to really worry about. And so on average, our customers reduce data volumes by 48% after that transformation. So that's and again, that's not something that you have to actively do. It's something that's built into the platform. And so that's on average across all of our customers. They reduce data volumes by 48% while actually improving their troubleshooting metrics. And a note about reliability and the performance, because that's what this session is about, right? Our promised SLA is 3 nines. Our actually delivered SLAs to our customers are better than 4 nines. And so, we have one of the most efficient engines for collecting and storing your data, and we'll show you the details of it in another slide coming up. So really, the founders of the company learned how to do industrial, highly performant, highly available storage from building M3 at Uber. And so we've proven to scale that to 2 billion data points per second. And we do all this, again, using open source standards. All the ins and outs of the platform use open source standards, from ingestion to querying to dashboarding and alerting. And so how we've kind of built the platform, and these are some questions to ask about SLAs, right? So basic things, right, is, what is the vendor's uptime guarantee? And also ask what has been traditionally delivered. That's kind of the first, some of the first questions to ask, right? So our SLA for Chronosphere is 3 nines, but as we mentioned, we've been delivering historically 4 nines. And again, ask what the vendor has achieved over the past 12 months. And this, I think the slide says 99.95. We've actually done greater than 4 nines. So I actually need to fix that slide. How does the vendor check the systems that are, check that systems are available? And so for us, we check all the read-write paths that are available to ensure that data is persisting as expected, no data is lost. We outline a lot of this on our website too, you can go check out. But I think as a comparison, some more other vendors in the market will do simple endpoint pings. So it's a different way of looking at it. And ours is a little bit more detailed. And, how do they define downtime? When we define it very strictly around non-availability of the Chronosphere covered services for a duration of more than 2 minutes. And I think some competitors in the market, again, looking at how different vendors do this, and you need to ask about this when you're evaluating vendors. It's generally the timestamp of the alert in the vendor's monitoring systems or a timestamp of a customer's ticket. So that's an important distinction. And where can you check status? Every customer of Chronosphere gets their own dedicated status page. That's opposed to some places where you might only see an aggregate of status for the entire system, but not specific to you as a customer. So just something to note. And a little bit about how have we historically been able to deliver the 4 nines, right? And again, this is all presented on our website as well. But as Joel kind of mentioned, right, the single tenant deployment. But in addition, the industrial resiliency, right? We store 3x data copies in diverse availability zones. So we ensure strong consistency on quorum writes and reads using dispersed regions. So we're geographically dispersed. So we have highly consistent data collected across those different availability zones. That's how we're able to do this and deliver historically 4 nines of availability. And so just in, wrapping up, like Chronosphere is built and designed for these unique reliability requirements that you need in a cloud native infrastructure. It's designed for both DevOps teams, SREs, all your developers, platform engineers can get the right data in the right context, and it's optimized to run and support, a complex interrelated microservices architecture running on a large fleet of containers. And so again, the biggest things that we said, 5 times more reliable than most of the other solutions. You get a 48% average reduction in data and 55% less time troubleshooting with much higher reliability. And so we did a commissioned study with Forrester to kind of get to the economic value of this. So what does it mean when your platform is more reliable? Because when we were doing this economic impact study with Forrester Research, I think our thinking going into it was that the data volume reduction would probably be the biggest driver of cost savings. And it actually turned out reliability of the platform was. So the high level numbers were that customers, had 165% return on investment with Chronosphere, and they got that payback within 6 months with a net present value of 4.9 million. And if you're not familiar with the Forrester TEI report, it's basically Forrester interviews a bunch of our customers. Without us, we are not involved in that interview process. We just get them the customers, and then they interview them on their own with no input from the vendor. They do this for a lot of different vendors. And what they do is from those interviews with those customers, they build a composite organization that represents all of them. And so the composite organization was a generic kind of multinational B2C company with $1 billion in annual revenue and around 5,000 employees. And on average, 60% of their metrics are actually stored, and their metrics growth year over year for over 3 years was about 100%. And some of the some of the discovery here and what they achieved was, of course, significant cost savings from data reduction, certainly. But they also had customers that were reducing the number of Sev 0, Sev 1 events. So when they happened, they were shorter. So, and they avoided a lot of that permanent revenue loss. But what I wanted to highlight here was the reliability of the platform, the reduced number of incidents and the higher reliability, and that higher reliability reduced the time spent triaging events. That was a 2/3 reduction in administration of the actual platform itself. So a huge difference. Reliability was one of the biggest drivers of that 165% ROI. So it really matters having a more reliable platform than just pure license costs and things like that. The reliability was a huge driver of the cost savings. And I think Affirm is a great case study in this. So before using Chronosphere, Affirm had a downtime event around Black Friday that was hugely disruptive to their business with their older observability platform. Since they've brought Chronosphere on board, the numbers to call out here is, again, a 64x improvement of the availability of their observability platform. And the impact that had, improving their mean time to detect 10x, $5 million in annual savings from their previous solution. And I think the biggest thing to highlight, right, it's 14,000 hours of engineering time that they've reclaimed annually. Imagine what you could do with 14,000 hours given back to your engineering teams. And so just to sum everything up on what we kind of went through, right, in summary is that monitoring tooling that is built for cloud doesn't necessarily work for cloud native. We've shown the difference between the two architectures and what the differences are and what that challenge presents, especially in the context of reliability of your observability platform itself. Very important to dig into the SLAs, know the historical delivery and how they actually calculate all of it, really know the SLAs piece of it. Getting credits is that's not really helpful. You are still had a problem, even if you get service credits later. The whole point is to avoid it in the first place. Know the economic impact of when your observability platform either is down, partially down, or is just suffering from poor performance, right? As we mentioned, the three things, your business just comes to a halt, your troubleshooting takes longer, it costs more, and you're burning out your engineers when you're constantly fighting these fires. And what we've hoped to show you near the end of this presentation was just the fact that the cloud native environments, they need cloud native observability. The older tools, it's going to be hard to drag those into the new world. They were built for that cloud or traditional world, and trying to use them for cloud native, we've shown that is just not a sustainable path forward. And so we wanted to take a sec to promote some of the upcoming webinars. So we've kind of given you some high level data points here. If you actually want to see the platform in action and see some really cool stuff, I really recommend the session coming up with John Patokny and Scott Kelly, which would be kind of more of a technical demo for proving the value. Like, how do you justify your observability spend? I think that's a real challenge for a lot of companies. You may be getting pressure from the CFO or a center of excellence team that's saying you got to get your costs down. And I think it can be very hard for a platform team or an application team to justify, no, I need all this data. Here's what I'm actually doing with it. It can be hard to account for that. So they'll show you in that webinar how you can actually one, get your data under control, but also account for it, and be able to justify this data is, justify the value of all the data. And then Paige Cruz with Mofi from Google Cloud will be actually showing you how to effectively monitor your Kubernetes environment in that upcoming session. So really 2 great sessions coming up in May that we're looking forward to. And so some additional resources from Chronosphere, I definitely recommend you check out the customer stories page. That can actually, I'm sure you'll find a story that you can relate to personally, whether you're kind of doing it yourself with some open source observability tooling, or whether you have a current APM tool. There are customers here that have come from either of those worlds and migrated to Chronosphere. The Forrester Total Economic Impact study is on our website, as well as a calculator that you can actually run through on your own, put in some simple details, and get an initial idea of what are some of the benefits I can get if my platform is more reliable and I can reduce my data volume. And there's a great ebook there about getting the facts about cloud native observability. And of course, we're happy to talk to any of you. You can schedule a conversation, get a demo on the platform. We're happy to do it. And with that, we can kick off any questions that have come in. If Han, you want to kind of show us any questions that have come in during the webinar, we're happy, Joel and I are happy to try and answer them.
Yeah, sure. Since we only have 3 minutes left, we will try to cover as many questions as we can do. So the first one, in a DevOps environment, how do I discover my observability is done? Joel?
Sure. Yeah. George touched on this one at the very end. Chronosphere uses a status page per customer, which we think is very important, and not a global status page. If you are in a current situation with your provider where you are relying on them to reach out to you, you should rethink that position, because when things go down, they are in the midst of a firefight, and communicating with their customers is not always at the top of their list. So I would just say, make sure that you have a plan that puts some of the control of identifying and reacting to those outages in your hands, and not entirely relied upon from your provider to reach out to you and make you aware.
Right. Then the next question, we are moving to the cloud with Kubernetes and the microservice. Is observability uptime easier or harder in that world?
George, I'll let you weigh in here, but it's harder. I don't think there's any debate about that. As things spread out and are interconnected across networks and meshes, all of the complexity, it multiplies, it grows exponentially even. So the challenges that you are facing when your application and your infrastructure is in a monolithic, everything is all tied together, versus a distributed system in whatever form that takes for your organization, your challenges increase. I don't think there's any debate about that.
Yeah, it's hard for me to even add to that. It gets exponentially more complicated, especially as you mentioned earlier, right? The ephemerality of containers is another, and just, I think a lot of older tools just are not very good at understanding the dependencies amongst microservices, and that can, again, something downstream affects your microservice, and it can be hard. It's much, much harder to isolate the cause of that.
Yeah, and because of the distributed nature of the systems we're talking about, partial outages are more likely, which can be difficult. If your provider is not fully up and running, it may be hard for you to see what is actually happening and realize that you have an observability downtime problem, which, as we talked about earlier in the session, creates a lot of churn inside of your engineering organization.